Pre-college, trig applications. So we're definitely going to need our calculator for this. This is basically a combination of the two previous videos. The two previous videos, we learned about the law of sines tool and the law of cosines tool. And we can use both of those to solve questions such as these that, well, these are force questions. I'll talk about some force questions. But you're also going to see questions that are just regular, you know, you have a triangle and solve different things. But it's all about using the law of sines and law of cosines. See, those two formulas are tools that help us solve for angles and sides in triangles and things like that. When you know, if you have a triangle, it's not a right triangle, but you still need to find the length of a side. You can use law of sines, law of cosines, stuff like that. Granted, if you have enough information to do so. But anyways, it's basically using the law of sine and law of cosine formulas to help solve problems. Now, force questions we see here, when they talk about two forces, force questions always have the same picture. So whenever you have a force question, you want to draw a picture of a parallelogram. And so that's what I'm going to do right now is I'm going to draw a picture of a parallelogram. Not the best parallelogram, but it's close. So let me just update that a little bit. Oh. All right, so here's a parallelogram. And you also want to draw in a single diagonal of the parallelogram. Because when they talk about two forces, think of this as one force, and think of this as the other force. The diagonal is like is called the resultant. And because what happens is, you know, if you have, you know, say, you know, one car, you know, if you're tied, you know, say there's like a boulder right here, you know, a rock or something like that, and you get one car, you know, tied to that rock, drives off in this direction. You have another car that drives off in this direction. The boulder is going to go. The result is going to be in between the two. And so that's basically what's happening here with these force questions. But generally, you just want to draw this picture. And when they talk about the forces, we're talking about the sides of the parallelogram. And when they talk about the resultant, we're talking about the diagonal. So the diagonal is the resultant. All right, so let's see what this question is really saying here. Two forces act on a body to produce a resultant force of 70 pounds. So anytime they talk about the resultant, that's your parallelogram diagonal. One force is 50 pounds and forms an angle of 67.40 degrees with the resultant. Okay, so your picture is not going to be drawn to scale here. That's okay. But one of the forces is 50 pounds. So if we put a 50 pounds over here. Now, whenever they give you force stuff or angle stuff, keep in mind that for a parallelogram, we could always put that number somewhere else. So one force is 50 pounds. Well, if this side is 50, that means this side is 50. And I could have chose these two sides. You basically just need to pick one. So that side would also be 50. Then they say that that force forms an angle of 67.40 degrees with the resultant. So that would be the angle of the force and the resultant is 67 degrees 40 minutes. I can also put that here, 67 degrees 40 minutes. And so what we end up doing is we draw a parallelogram, but really it's a triangle problem. You get two triangles happening when you have a parallelogram like this. So just move this up a little bit. All right. So they gave me a force. I put it on here. I chose to put it here, and I also labeled it on the opposite side. They gave me an angle. Well, I know it also goes here. You can think of it as alternate interior angles or whatever. Basically, whenever you're given a parallelogram, like if they give me this angle, I also put it here. If they give me this angle, I'm also going to put it here. If I figure out this angle, I could also put that there. Opposite angles are congruent. If they give me this side, I could also put that there. If they give me this side, I can also put that there. The only thing that doesn't get put in two spots, is the resultant itself, the 70. This is the only thing that's only going to get written, you know, the value of the resultant, the 70 we have in this problem, is the only thing that gets put in one spot and one spot only. Everything else you could put in two places. All right, so what do they want to know? They want to know, to the nearest pound, the magnitude of the other force. So the other force would be this, or this, because it's the same thing. And so you want to focus on this really as just a triangle problem. So again, if I really just isolate one of my triangles here, like let's take a look at just this triangle here now that everything's labeled, or I could do the top one because it's the same triangle. What do I see? I see that I have a side of the triangle that is measuring 70. I have another side that's measuring 50, and I have a force here and an angle here, and that's about it. So what I need to do is I need to figure out this side. Well, is it going to be law of sines, or is it going to be law of cosines? And so remember, we always want to look for law of sines first. Law of sines is the easier one. But what you need for law of sines is you need a complete set. You need a side and angle across. So here's our side of 50. Do I have the angle across from it? That would be here. No. I have this side 70. Do I have the angle across from it? No. I have this angle 67 degrees 40 minutes. Do I have the side across from it? No. So can I do law of sines? No. So this is clearly a law of cosines question now, and there are three sides involved in one angle, and so that's it. The side that I want is the one opposite the angle I'm using, so that's how we're going to go about this. And so that would be that side squared equals your other two sides squared, so 50 squared plus 70 squared minus 2 times 50 times 70, and then also squeezing in there is times, and I'm not going to be able to fit it in. Let me move this down and over. So also times cosine of 67 degrees 40 minutes. And so what we did yesterday was the law of cosine. That's basically what this problem is. So the side that I want squared and is across from the angle that I have. That's on the left side. The other two sides squared minus 2 times the other two sides cos 70. And so I'm solving for the x term here. So I need to simplify all this stuff over here. And that's where your calculator is going to become really useful. So we got 50 squared is that. We got 70 squared is that. And then we also need to know what is negative 2 times 50 times 70 times cosine 67. Now I actually, whenever minutes are involved, I do need to do those symbol. So I need to do 67 degrees. You get that in the angle folder here, which is second apps. Second apps, and it's my top choice. Number 1 is my degree symbol, and then I do 40, and I need the minute symbol, second apps, and that's number 2 is the minute symbol. And enter that whole thing in. And I'm afraid I'm going to be, oh, I'm on degrees. That's good. Or it's going to be our radians, and I'd have to do it all over again. But it comes out to be this whole thing. So let's see here. Q500, 4900. So 2500 plus 4900 minus that whole piece. Let's do 2659.96. 2659.96. And then let's add all those pieces together. And so I'm going to just do my second answer there and do my answer plus 2500 plus 4900 is about 4740.04. So 4740.04. 4740.04. But that's my x squared. I want x, so I'm going to have to do second x squared, the square root, and I'll just do second answer to grab that whole thing. And that's giving me 68.84. And what are we doing here? To the nearest, what does the question say? Nearest pound. And so that would be near, like a whole number. So the answer would be 69. And so x, my other force, would be 69 pounds. All right, so this is what a force question is like. And you're just gonna, like I said, label everything you can. If you know if the resultant can go in only one spot, if they give you that value, but everything else they give you, put it in 2 spots. And then based on what you need, you got to figure out: can I do law of sine? Can I do law of cosine? and you just go about the problem like that. So we'll try the rest of these in class together tomorrow.